Most of us grow up imagining an electron moving around the nucleus, just like a planet moves around the sun. But what if I told you that this picture is actually wrong? Then what exactly is an orbital? That's what we will understand today. Bohr proposed that electrons occupy only certain allowed circular orbits. It was a brilliant model because it correctly predicted the energies of hydrogen. But quantum mechanics shows us that electrons are not described by well-defined paths at all. According to quantum mechanics, an electron is not described by a tiny particle traveling along a fixed path. Instead, it is described by something called a wave function. But wait, if the electrons behave like a wave, why can't we simply draw its path? Because trajectories do not describe waves. Wave functions describe them. So where does this mysterious wave function come from? It comes from solving the Schrödinger equation. In a hydrogen atom, the electron experiences the electrostatic attraction of the nucleus. This attraction is described by the Coulomb potential. Now something remarkable happens. The Schrödinger equation doesn't give just one solution. It gives many allowed wave functions. The simplest solution is called the 1s orbital. Another solution is the 2s orbital. Notice that this mathematical form is completely different. Until now, the wave functions depended only on the distance from the nucleus. But some wave functions also depend on direction. Combining these gives another allowed wave function, the 2p orbital. In general, every hydrogen wave function consists of a radial part and an angular part. So here's the entire story. We have Coulomb potential, which leads to Schrödinger equation, whose allowed solutions are the wave functions. And these allowed wave functions are called atomic orbitals. We have been calling these orbitals 1s, 2s and 2p. But have you ever wondered where these names come from? They are not arbitrary names given by physicists. Each allowed solution of the Schrödinger equation naturally emerges with a unique set of numbers. These are called quantum numbers. The familiar names 1s, 2s and 2p are simply a convenient way of representing those quantum numbers. So remember the biggest takeaway from today's discussion. An orbit is a path. An orbital is an allowed wave function obtained by solving the Schrödinger equation. But one question still remains. If every electron is identified by its own quantum state, can two electrons occupy exactly the same one? We will answer that in the next episode.